Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is 0 by 1 Knapsack problem using backtracking. This topic you will find in third unit, topic number 11. Now, as far as this topic is concerned, we'll be going to talk about what is backtracking approach to solve 0 by 1 knapsack problem. There are many other algorithm techniques where we were solved 0 by 1 knapsack problem using greedy method and dynamic programming and brute force approach. So this video is focused about backtracking approach. We'll solve 0 by 1 knapsack problem using this backtracking approach. Now let's get started. So basically it is an optimization problem. So what is optimization problem? The problem solution will be either maximum or minimum. So always 0 by 1 knapsack problem solution will be maximization. That means when you given with positive n number of positive weights, that is wi, n positive profits, that pi, and a positive number m, that is the knapsack capacity. And the constraint is what? Always the weights of the individual objects what we are placing inside of the container, that should not be greater than the capacity of the bag, and the profit always should be maximization. And that's what I said. I told you that it is an optimization problem. Now, so we'll solve this problem using backtracking approach. Now, what is backtracking? Backtracking is such a process where we'll place in a container the first item with a profit of 10 and with a weight of 4. So where your bag capacity should not exceed 12, right? Now, if you put all the items in the bag capacity will get overloaded, right? So the one thing is very clear that you cannot place all these items inside of the bag. But you can place any one item such that the weight should be equalized or less than or equal to m, and the profit should be maximizes. Keeping this constraint in the mind, we will place these items inside of the knapsack or in the container or in the bag. Now let's see how knapsack algorithm will works. Now let's see that I wanted to generate state space tree for sure. That is what the solution using the backtracking approach and using DFS. So for an idea, I'm discussing this thing with you that so when you started to place the item, that you will place the first object inside of the bag, correct? Now, once after you place this item, the weight which is having 4 kgs, let's assume that the 4 kgs weight has been placed inside of the bag. Now, how much weight you can still more have to keep the item? So, now the bag capacity is what? M minus wi. M is what? 12. Wi is what? 4. That keeping in the mind that I am placing the first object. Now it will be 8. So still 8 more kgs are left to place inside of the bag. Now I am choosing the second object, which is 6. So 8 minus 6, it will be 2, right? So now I have the weight which is of 2 kgs, but where the third item weight is what? 3 kgs. So I cannot place this 3 kgs in 2 kgs of worth. What I'm going to do is I'm going to apply bound function. What is this bound function? The cost what you are left with, the cost should not be more than what you wanted to get, correct? So now bound function is a constraint to apply on the knapsack to kill that node which is generated in the state space tree. Now let's see how state space tree will get generated. So the first node I'm just taking now. X1 is equal to 1. So I told you already in the previous videos that this approach, backtracking approach, uses DFS, depth first search. So I am placing X1 object inside of the bag. So when I place X1 object, then I can explore the node, that is what? E node. Now my solution state is what? I have been existed, or I have added this X1 object inside of the bag. Now again go ahead. So when you place X1 object, what is the weight we were consumed? That the weight is actually 12, and 12 minus the first object weight is 4. it becomes 8. Still you can use 8 kgs of weight, correct? And the profit also you can calculate over here, that profit still till this you got only 10. Now so place the third object. So it is what? x1 x2 is equal to 1. We placed x1 and x2 also. When you place x2 item, then that is what third node is got generated. So the leftover weight is 8 minus 6 and it is 2. The profit is what? 10 plus 15, which is 25. Now we will be generating the fourth node. So always before you generate the E node or exploration of node, always will be based upon these constraints. Now fourth node, by the time I generate fourth node, I have the weight, leftover weight is 2 and the profit is 25. Now let's see, if I wanted to place the third object also, then what happens? Remaining weight is only 2 kgs, but the weight of the third object is 3 kgs. That means the weight what is left, it is lesser than what you wanted to place, correct? Or else the weight what is you wanted to place is greater than the weight what is available. So the bound function will be applied and will kill this node. That means you cannot place x3 object. When you will not place x3, there is no further exploration from this side. Now we'll come to this side, that x3 is not 1. That means I am not placing x3. So in the sense what? I placed x1, I placed x2, now I am not placing x3. Let's see, if I don't place x3, now I can place what? I can place x4. So I am generating fifth node. So generating fifth node is what? I am placing x1, x2 but not x3 but x4. Okay, so I am just taking out this x3 equal to 0 and I am placing x4. Now when I place x4, what happens? So x4 weightage is what? 4. But again it is, the available weightage is lesser than the weight what you wanted to place inside of the bag, or else it is more and it is less, greater. So bound function will be applied and kill this node. Now what I can do? So the third option, I am not placing x3, I am not placing x4. Now let's see, if I place x5, what I'll get? x5 is equal to 1. Now when I place x5, what happens? I have placed 1, 2 and this time 5. 5 weightage is 2, available weightage is 2. Yes. So we have a constraint, that is what? Wi less than or equal to m. It's equal to condition. That means if I place this 2 kgs of weight inside of 2 kgs of availability weight, it will give you balancing thing, right? So that means your solution is what? That placing of x1 comma x2 comma x5, this is the solution. Okay, or else the fixed size solution is what? 1 comma 1 comma 0 comma 0 comma 1. This is what your solution of 0 by 1 knapsack problem.